So last time we created a very simple smart contract just with using the ops code of Ethereum VM. And it worked well, but it's time to create something more complex, just using the stack and memory and checking the debug. So let's go back to the reference, the Ethereum.io, where we can use all of the you can find all of the available ops code. And let's say I would like to add two numbers. So first, let's try to write in assembly. And after that, we can create the data. So I need to add two numbers, right? Which will add two things from the stack. The code will be 01 for this one. And let's write in 01. This is not the offset or some index, but this is the binary representation of the add command. So, but first we need to put the two numbers to the stack because it reads two numbers of the stack, and the end of the operation, the result will be put back instead of these, which are removed, which is clearly visible in the stack input, stack output. So let's say I would like to add the 01 and 02, which means that I'm adding 1 and 2. I'm wondering what can be the results. So push 1 was 60, as far as I remember. Yes, 60 and the numbers. So the binary representation of this one is 61, 60, 02. And it's stored on the stack right now. But the problem is that with the return, which was F3, we can return something from the memory, right? This is the offset and length. So let's quickly, this will be the offset, which is again 6000. And we need the length. Let's say still we are returning with 32 bytes, which means that I need 020. Okay, so it will return the memory content from the offset 0, and the 32 bytes will be returned. But what I need is just putting this data from the stack, which is calculated, to the memory, right? So I have an mstore operation, which does exactly the same. I need the offset and the value, and the value will be stored in the 32 bytes of word in the memory. That's nice. So right in here, the result is in the stack. So but the result is just a value. I need to put something here, which is the offset where the results will be stored, right? After this line, the top of the stack is this one, and the second value is the result from this one, which is fine because after that we can just call the mstore. Okay, so mstore is 52, right? This is the 52. And push 1, we know that this is 60 and 00. Okay. So we are pushing two numbers, adding, and which means that they will be removed from the stack and the result will be added. After that, we are just pushing the offset, and store will store this number on the offset 0. And after that, we can just return with the same number. So it looks to be a good program. So let's try to execute it. Okay, we don't need this one anymore. Okay. And what we need is a tx submit with account key 1, and the data is this one and this one and and this one and this one and 52 and this one and this one and this one. So it seems to be a more complex application, but let's check what's happening. Oh, status 1, this is a good sign, right? It seems to be committed, but let me check the debug. This is a separated RPC call, which is enabled only because this is a debug server. Oh, and the return is 3, so we added 2 values. That's awesome. It works very well, and we can see the stack before the execution. So this is the result of the previous line, right? We are just putting 1 and 2 to the stack. The 3 will be added, right? After we call the add. These are removed and the result is added. We are just adding one more, the offset. And here we can see that the memory contains the 3 instead of just zeros. And here we are just pushing again the stack to the offset and the length of the return value. And we are saying that, okay, the first 32 bytes from the memory is supposed to be returned. So it's returned, it's fine. We can execute real commands on the blockchain, which is fine. The only problem is that we don't know anything about this contract address. What is this, right? There's supposed to be a new contract which includes some kind of code, but it seems that we just executed this add command. So let's check this contract. What's here? Contract. Okay, we can say that this is our contract, and still we use the key 1. And let's ask for the code, the source code of the contract, right? It's supposed to be something which can be executed. Oh, you see that the source code is the return value. So it seems that we execute a code, and what is returned it's stored as the source code of the new contract, which is very nice, because in that case we can commit real code. The only thing what we need to do is here, instead of returning with 3, which is the result of operation, we should return with our source code, for example, with something like this. So we need an application which returns with this one, because this is a normal source code. So this is what we can do next time.